Hello, everyone. This is the lecture on optimal consumption bundle and corner solution. In our previous lecture, we tried to consider the optimal consumption bundle as an interior optimum. So, meaning that the consumer buys positive amounts of both goods, assuming that is consuming only two commodities. So, in reality, consumers might not purchase positive amount of all available goods. For instance, a consumer who has no car cannot consume positive amount of some goods. A consumer who has no automobile, who has no house, we expect that particular individual not to consume automobiles or house. So he or she consumes zero amount of those goods. Now, again, take the instances of a consumer who does not buy alcohol or who does not drink alcohol. So we don't expect that individual to spend his or her money on alcohol. So, as a matter of fact, he consumes zero amount of that good. So the assumption of the consumer buying some amount of, let's say, good X and then some amount of good Y does not occur here. We have a situation where it does not consume one particular good. That is to say, it consumes zero amount of the good. So what happens here is the marginal rate of substitution is equal to the relative price of the goods at a corner point. In other words, the budget line is tangential, the indifference curve is tangential to the budget line at a particular point. So the optimal consumption bundle there will occur on one particular axis, either the x-axis or the y-axis. So this depends on the relative slopes of the budget line and the indifference curves. If the slope of the budget line is less than the slope of the indifference curve, then we expect the individual to consume only good X. So the optimal bundle is going to be on the horizontal axis, the x-axis. That is, it consumes all of X and none of Y, if the slope of the budget line is less than the slope of the indifference curve. If the slope of the budget line is greater than the slope of the indifference curve, then the consumer only consumes good Y. So its optimal bundle is going to be on the vertical axis, on the y-axis, at a point where it consumes only good Y and none of good X. So this is what we are going to study today. We are going to look at a corner point. We are going to look at the optimum at the corner and not at a point where the budget line is tangential to the indifference curve for positive amount of the goods. So the consumer's problem is to, one, maximize his preferences given his income and a set of prices. Now the prices are given. So you see, when we try to formulate the consumer's problem, we have the objective function, which is what? To maximize utility or preferences, subject to what? Subject to what? And subject to what? The constraint, the budget constraint. Now, even though he wants to derive utility from the consumption of two goods, but is constrained by his income. There is some amount of money that he can only spend. He cannot spend beyond that. So that is the constraint here. So subject to the consumer's income and the set of prices. Again, it depends on the prices. If the prices are out of reach, he's not going to buy those goods. He's not going to choose them. He's not going to make a decision on those goods. Then, the second point here I want to make is that the consumer chooses the consumption bundle that equate the marginal rate of substitution to the relative price of the goods. That is to say, the marginal utility per dollar spent on each good must be the same. The marginal rate of substitution is equal to the relative price of the goods. The marginal utility per dollar spent on X is equal to the marginal utility per dollar spent on good Y. So if the consumer is faced with N commodities, it means that the marginal utility per dollar spent on good 1 is equal to the marginal utility per dollar spent on good 2 is equal to the marginal utility per dollar spent on good 3, and so on up to good N. So at the optimum point, each optimal bundle gives the consumers the bang for the buck. Now let's look at the optimal bundle here, which occurs at a point where the marginal rate of substitution is equal to the relative prices of the two goods. Clearly, at point B, we notice that the marginal rate of substitution is not equal to the relative price of the goods, so that is not optimal. That is a non-optimal bundle. Now, let's look at point A again. Point A, the bundle there is XA and XAYA, right? So, but the marginal rate of substitution is not equal to the relative price of the good. So that is not optimal as well. But what is optimal here is point E. At point E, the consumer consumes positive amount of the goods, and the marginal rate of substitution is just equal to the relative prices of the two goods. So that is the optimal point. So we see that at that point, the indifference curve is tangential to the budget line. In other words, the budget line is a tangent to the indifference curve at point E. Now we notice that at point A, the consumer is on a lower indifference curve, and likewise at point B, the consumer is on a lower indifference curve. So it prefers only to be on the higher indifference curve, which is tangential to the budget line, because it gets more utility when it's on the second indifference curve. Now let's look at Konar solution here. The last topic we talked about the interior optimal points, right, of the consumer. So that is to say, the consumer's optimal consumption bundle contains positive amount of all goods. This is not true in all cases, because some people do consume zero amount of some goods. As I said earlier, if you don't own a house, then we expect you not to consume that commodity. Likewise, if you don't drink alcohol, we don't expect you to spend your income on alcohol. So that means you consume zero amount of that particular good. Again, if you are not a smoker, you are going to consume zero amount of cigarettes, as opposed to somebody who smokes. So the Konar solution, therefore, to the consumer's optimal choice problem occurs at a point where the consumer consumes zero quantities of some goods. The optimal consumption bundle in this particular case occurs on either the x or the y axis. So it is either on the x or on the y axis. If it occurs on the x axis, then it means that the consumer only consumes positive amount of x and then zero amount of y. If the optimum occurs on the vertical axis, then it means that the consumer only consumes y and none of x. Now let's look at the quasi-linear utility preferences and corner point solution. If we look at the diagram here, we see that the consumer optimal bundle is at point F on indifference curve U2. So we notice that at point E, we notice that at point F, the marginal rate of substitution is not equal to the relative prices. And then at point G, the marginal rate of substitution is not equal to the relative prices. So the point where the marginal rate of substitution equals to the relative prices is at point E. So it occurs at the corner, so just on the x-axis. So this means that the consumer consumes only a positive amount of x, zero amount of y. Now let's try to solve a problem. Now if we look at this quasi-linear function, the individual consumes two goods, x and y, and then its utility function is quasi-linear. Why do we say it's quasi-linear? It is because it has a linear component as well as a non-linear component. The non-linear component there is xy, and then the linear component is 10x, right? Likewise, if you have a function with a utility function which says u of xy is equals to x squared y plus 3x or 10x, then that function again is quasi-linear, because one part is non-linear and then the other part is linear. So the price of good X is $1, the price of good Y is $2, and suppose its income is $10. What is the optimal bundle of these goods? So how do we do this one? So the first thing we have to do here is we can either use the Lagrangian function to do this, which is a little bit sophisticated, or we can use the easy method. We just find the marginal utility of each of the goods and then divide them by each other, so to obtain the marginal rate of substitution. So we get the marginal utility of good yx, which is what? The uxy dx, which is just y. And then y plus 10. And then the marginal utility of good y, the marginal utility of good y with respect, the marginal utility of good y, which is derivative of u with respect to y, is just equals to x, right? So once we have those two, we just divide the marginal utility of good x, which is y plus 10, divided by the marginal utility of good y, which is x. So we have y plus 10 over x as the marginal rate of substitution. So the optimal bundle for the quasi-linear preferences is obtained by just deriving the marginal utilities of the two goods. So at equilibrium here, we know that the marginal utility per dollar spent on X must be the same as the marginal utility per dollar spent on Y. That is MUX over PY is equals to MUY over PY. So notice that the price of good X is 1 and then that of good Y is 2. So from the equilibrium condition, it follows that mu x, which is y plus 10 over px is 1, is equals to muy, which is x, divided by py, which is 2. So if we solve this one, we're going to have an equation of x in terms of y as x equals to 2y plus 20. So the budget constraint of this consumer, we know for sure that is x plus y plus y, x plus xpx plus ypy equals to m. So the budget constraint is xpx plus ypy equals to m, where m is the income of the consumer. Now, since the price of x is $1 and then the price of y is $2, so the budget line becomes x plus 2y equals to 10. Now, plugging for x into the budget constraint and solving and gives us 4y equals to minus 10. If we solve that, we're going to have 4y equals to minus 10, and then y star equals to minus 2.5. Is that the answer we are looking for? No, that is not what we are looking for, because in economics, consumers don't consume negative amount of a particular good. So this is not an optimal point. So this is the reason why we say that some other goods, the consumer is not going to consume some other goods. So in this particular regard, y star is equals to minus 2.5, which is negative. So that is not an optimal point. So if we substitute for y star into x, we're going to have x star equals to 15. So it means that with this particular solution, the optimal bundle is 15 and then minus 2.5. But that is not the correct answer, because we have a negative value of x. So we need to find other ways of computing or obtaining the optimal consumption bundle. Now, if we look at this, we notice that the x star is 10 and then y star is 0. Now, that one is not 20, it's supposed to be 10. That was a mistake. So this one is supposed to be 10 and not 20. Okay, so it's supposed to be 10 and not 20. So x star, y star is 10, comma, and then 0. So because m over px there is 10, then m over py is 5. So x star, y star is 10, and then 0. It's not 20. Okay. Now let's look at this particular problem. So I want you guys to go home and solve this problem. Try to solve this. If you have some issues with that, please give me a call or maybe shoot me an email. Yeah, we're going to discuss that, okay? So, but I expect you guys to be able to do this one. It's not that difficult. All you need to do here is you have the quasi-linear function here. You differentiate with respect to f. You're going to have c plus 1. And then with respect to c, it's just f, right? Then once you do that, because here you have food, and then clothing, and then you have number of units of clothing on the x-axis, on the vertical axis, and then the x-axis you have the number of units of food, right? So that's what you're going to use to solve this particular problem. Now let's look at the case of perfect substitutes and the optimal consumption bundle. So this is a special case, which is different from the quasi-linear preference. Now for perfect substitute, we know the indifference curve is a straight line, it's linear, right? And then the budget line is also linear. But this is the case where we're going to compare the slopes of the budget line and the indifference curves to determine the optimal consumption bundle. So for utility functions involving perfect substitutes, the goods are substitutes to each other at some specified ratio. It could be like 2:1 or 1:2, right? So in this case, there is no interior optimum. When we have perfect substitute, there is no interior optimum. That is to say, the optimal consumption bundle does not contain positive amount of the two goods. So it depends on the relative slopes of the budget line and the indifference curve. If the slope of the budget line is less than the slope of the indifference curve, then we expect the consumer to consume only good X. So it's going to be on the horizontal axis. If the slope of the budget line is greater than the slope of the indifference curve, then it's only going to consume Y and none of X, and it's going to be on the vertical axis. So this is a solution. This is a corner solution. So when this happens, we have a corner solution where the consumer only consumes one group and none of the others. So we have a corner solution. Yeah. Now, if we take a look at this diagram, we notice that we have Coca-Cola on the vertical axis and then Pepsi on the horizontal axis. So we have U1, U0, green line, and U1 and then U2. And we see the red line represents the budget line, M over PY, then you have M over PX on the horizontal axis. That is the budget line. So what happens here is we see the point where the budget line and the difference curve meets. So those 2 points are the optimal consumption bundle of the consumer in this particular regard. Let's try to solve this problem. We have a consumer. Utility function is giving us 18x plus 3y, where x is the amount of Pepsi consumed and y is the amount of Coca-Cola consumed. So if the price of a can of Pepsi costs 50 cents and a can of Coca-Cola costs 20 cents, now draw the consumer's budget line if his monthly income is $5. So what we say here, we know the budget line is what? X px plus y py equals to what? M, right? Where M is the income. So we know what is px. Px is what? 0.5, right? So it's just 0.5 times x, which is 0.5x plus what? 0.2y. So 0.5x plus 0.2y is equals to 5. So that is the budget constraint, right? So how do we do to get the budget line? Here, it is simple. All we need to do is to express y in terms of x. So if we have 0.5x plus 0.2y equals to 5, we can make either x as a function of y or y as a function of x. So if y is a function of x, then it means that the intercept term occurs on the vertical axis. If x is a function of y, then the intercept term occurs on the horizontal axis. So it is only those 2 points that we're going to connect. Once we connect them, we're going to have a straight line, and that gives the project line. Okay. Now let's try to look at the problem further. So we notice that the budget constraint of this consumer is given as what? 0.5 plus x plus 0.2y less than or equals to 5, right? So y equals to 5 over 0.2 minus 0.5 or 0.2x. So you see what we did, what I did here was I just take 0.5x to the other side of the equation, and that gives me minus 0.5x. So if I divide both sides by 0.2, I'm going to have 5 over 0.2 minus 0.5 over 0.2. So, which is y equals 25 minus 2.5x. So, here the intercept term there, 25, should be on the vertical axis. And then minus 2.5 is the slope, which is what? Px over py. So the first part of that question is this, the solution to the first part. Now you see if y equals to 25 minus 2.5x, so 25 there is the intercept term, which is on the vertical axis. And then if we try to express x in terms of y, we're going to have x equals to 10 minus 0.4y. So 10 there is the value of the intercept term on x. So we put 10 down there. We connect those 2 points. We have the budget line. So remember, this the slope of this one is what? Minus 0.5 over 0.2. So if we look at the B parts, we notice that the utility function u of xy is what? 18x plus 3y, right? So we are required to draw the indifference curve for this. Remember, this is the indifference curve for this perfect substitute preferences is going to be straight line, right? So what we do here, we start from u0, which is the lower utility curve. So in the question, they say it's 180. And so we set x equals to 0 and then solve for y. And then later set y to 0 and then solve for x. So that's what we're going to do here. So if we take 180 equals to 18x plus 3y, and then we set x equals to 0, that means 18x becomes 0. Because 18 times 0 is just 0 plus 3y, which is 180. And if we solve, we're going to have 60. Similarly, if we set y equals to 0, then 180 divided by 18 equals to 10. So now we see that for the first set, we're going to have what? 60 and then 0, right? Now let's look at the case where u1 equals to 360. We do the same thing. We set x equals to 0 and then solve. We're going to have y, we're going to have what? Y equals to 120, right? Similarly, if we set x equals to 0, we're going to have x equals to 20. Now we do the same thing for u2. And once we have done that, we're going to have points on the difference curve as well. 10, 60. That is x is 10 and then y is 60. Then for u1, x is 10, y is 120. And then for u2, x is 30 and then y is 180. So we can represent these curves in the diagram. Now, if we look at the diagram here, we have u0 equals to 180, and then u1 equals to 360, and then U2 equals to 540. So we see the intercept time on the vertical axis. We have 60, 120, and then 180. And then on the horizontal axis, we have 10, 20, and then 30. Now we want to obtain the optimal consumption bundle of Pepsi and Coca-Cola. So as I said earlier, we can only do this one if we know the slopes of the indifference curves as well as the budget line. If the slope of the budget line is less than, if it is less than the slope of the indifference curve, then the consumer is only going to consume X, 0 of Y, right? So now let's look at the slope of the indifference curve. Now the slope of the indifference curve was what? Was MUX over MUY, which was 18 over 3, which is 6, right? What is the slope of the budget line? It is just, now we are going to take the absolute value there. The reason why we are taking the absolute value is because what? That slope is negative, right? Absolute value of a negative number is what? A positive number. So if we take the absolute value of the slope of the budget line, which is what? Minus 5 over 2 px over py, which is minus 5 over 2, that gives us just 5 over 2, which is 2.5. Clearly, 2.5 is less than 6, because the marginal rate of substitution is what? MUX over MUY is just 18 over 3, which is 6. So the budget line is less steep than the indifference curve. So what happens here is the consumer only consumes with X and none of Y. So that is what we are going to see shortly. So if we do that, then the optimal consumption bundle will equal to X star Y star equals to 10, 0. That means the consumer only consumes X and none of Y. So this can be represented in a diagram. Now we see the green line there represents that indifference curve. We know the indifference curve there is what? 180 equals to 180 equals to what? 18x plus 3y, right? So if we set x equals to 0, then y is what? 60. 80 over 360, right? If we set x equals to 0, what is y? If we set y equals to 0, what is x? So in that case, just 180 divided by 18, and that gives us 10, right? So originally, we know the budget line is 25, 10, those 2 points. So we notice that here, the difference curve and the budget line, they meet at what? At 10, right? So that is the optimal point. That is the optimal bundle, 10, 0.